Hello, everyone. You are welcome once again to today's lesson. And in today's lesson, we are going to continue from where we left off on the lesson on bearings. Okay, so today's lesson is going to be lesson 2 of bearings. Okay, so in our previous meeting, we have a look at, these two questions. Okay, the first one, we're asked just to find the distance. The second one, we're asked to find, the distance and what? And the bearing. Okay, so now let's look at the third question. So we'll be looking at more challenging what questions. I think so far, the triangles, resulting triangle, we had a right angle triangle, special situations. So usually when you get that, I've told you, you have to smile. Okay, so now this is what we are supposed to do. If you look at this question, let me go to the solution. Okay, slide then. Okay, I read from there. A ship sails from Port P to Port Q, a distance of 50 kilometers on a bearing of 135 degrees. It then sails 120 kilometers from Port Q on a bearing of 225 degrees to Port R. So move from P to Q, then Q towards R. Okay, and you are giving the positions, okay, of the point Q relative to P and the point what R relative to what Q. Okay, so quickly, let's go and have a look at how best to deal with this. Okay, I've told you for every bearing question, before you go and draw your main diagram, what do you have to do first? What was the advice? Hello, my professors, are you there? What was the advice? Before you go and draw your main diagram.
Please, you have to have a plan.
Okay, plan. So get a rough sketch of the situation for you to know the area of your page that you need, okay, most. Okay, so now this is it. So let's see. Okay, so let me pick my red. Okay, so we are looking at from port P to Q. So assuming maybe this is P, rough work. Okay, point P to Q. Q, the bearing is what? 135. So 135 will be somewhere here. Okay, so that is Q will be somewhere here. Okay, the distance is what? Is 50 kilometers. Then, okay, from Q to the point R. Okay, the bearing is 5. So it means that will be somewhere here. Okay, so this will be the picture, but this will be long. It is even more than twice, okay, what we have here, because twice this is 100, so more than twice. So indirectly, this will be the nature. Then we come in. So we'll deal with it. You know, you will need this side of your area more, okay, and you need to move up too, because you come down and move in this direction. Okay, so on that note, I can go and pick my straight edge and start, okay, my actual diagram. So I go and fix my, okay, port P. So let me fix it somewhere here by the nature of the diagram. Okay, my rough work. So P, okay, my 4 lines for the north-south, and this east-west will divide the 4 lines into 2 halves. Okay, so in this case, I have my true north here, and the point that I have there, my reference point is what? Is P. Okay, so I'm going to write P here. Okay, and from P, okay, to Q, we said the bearing is 135. So from here to here, it's 90. So if I know that 135 will be between 90 and 180. So where exactly or how much, okay, angle do I need, okay, to move from 90 to 135, and it will be 45, right? Okay, so it means the line that you are going to draw, okay, to sight what your Q, that line must, okay, be almost in the middle in terms of its angle, almost in the middle, because the middle will be 45. Is my point well made? Okay, so this is what we have. Okay, so at this point, okay, we should get this picture. I intentionally didn't make it, okay, 45. Other than that, I'm going to get too precise a picture. Okay, so this is the shortest distance between the two distances. Okay, the first distance from P to Q is 50. So you have to be very careful because if you make it too long, when you are going to draw the other one too, the other one too will be very long. Okay, so I think where I've gotten to is okay. All right, so at this point, I fix my okay, Q somewhere here. My professors, I hope you are following. Okay, and I've told
Yes,
you
please.
any angle that you add, okay, indicate, don't forget. So I added 45 degrees, so I won't forget. I will indicate. Okay, then what do? I come and, okay, indicate my cardinal point at the point, okay, Q. I know that that's the point Q, though I've not indicated. I'll draw the cardinal point, then after that, use that one to indicate. So very soon you will see a picture. Okay, and okay, you even see, we started with a rough sketch. How come we have this situation? Okay, so this is what we have. So I'm going to indicate my true north here, and this is the point Q. Remember, I've told you how to position it. You shouldn't interfere with any of your lines. Then now from Q to R, we are told the bearing is what? 135. So, oh, sorry, 225, forgive me. So from here to here is 180. Okay, so it means 225 will be between 180 and what? And 270. So if this is 180, I need how much more to get towards 225? Again, 45, right? Okay, so I need 45 more. So the 45 that I will add, okay, please take note, I will come and indicate. So in this case, my 45 degrees line, I know should be more than that, okay, or even twice more than that. So I know, indicates, let it be more than that, you know. So in that case, if I draw, okay, I'm going to have the situation. So I'm going to end here and indicate, okay, my cardinal points there. Because if I go further, okay, it will be problematic. At least I can see that it is more than what I have there. It's not drawn to scale, but it should still make sense anyway. All right, so this is the picture that we have. Okay, so I come and indicate. Oops. Okay, so now, okay, let me use the top since it's not going. Okay, so I'm going to get this. So you should be doing the same thing as well. So I have, okay, my true north here. Then I have the point, okay, R. But now I will come and join R and what P, then my triangle will be formed. So look at how nice, okay, the diagram is after considering also your angles and the distances. Remember, we've not indicated the distances. So you come and join this, which gives you what you have there. So in effect, remember here, we added 45. So you indicate the 45 degrees here. Okay, take note, it's usually very useful. Okay, so at this point, remember I told you, you always know one of the angles. So let's see if this is the angle that I can easily find. If this is the angle, okay, I should know this, okay, and know this one as well. But unfortunately, I know that this is 45, but I'm unable to determine this easily. Now, let's come to this. Okay, this I know is 45 degrees. I also know that if this is 45, the angle here is 45. Okay, it will alternate with this. So this will also be 45 degrees. Is my point well made?
Yes, please.
Okay, so at this point, once again, we are confronted with what? A right angle triangle. And I told you, if possible, as your rough work, okay, or just, okay, beside or where you have a space, okay, you go and draw and use it to do your analysis. So I will come, okay, so I'm really ruling my line to create my other page. Okay, I don't want to move to the next slide. So this is what I have. Oops. What is happening? Okay. All right. So unfortunately, my line is double, but no issues. Okay, I'm using that one to divide my page. So I come and draw my right angle triangle just here because the diagram that I have there somehow is busy. So let me move it here a little. So my right angle triangle to get a better picture of the situation at hand. Oops. What is happening? Okay. Okay. All right. So we are good to go. Okay. Then I come and do this. Okay. So I will join this. Oops. Okay. Okay. So this is what we have. You indicate your 90 degrees. Okay. But the triangle is right at Q. Then you indicate the 2 points, any of them anywhere. So P, then what? R. Okay, in the diagram, the main diagram, remember, we considered only the angle. So we didn't consider the distances. So let's go and indicate that. So we have, okay, between P and Q, the distance is 50 kilometers. Okay, then I think I'm done with the split edge. So let me, okay, take care of it. All right, so then from Q to R, okay, the distance is what? 120. So I have 120, okay, km here. Or I can even write it on top. Okay, so this is what we have. Okay, all distances, all angles that you considered must be indicated. Okay, so you've done that. So now to A, how to find A. A right angle triangle, so any distance, you should be very happy, okay, to find it. So we are looking for this distance. Okay, in the right angle triangle here, let's come and do the needful. PQ, you know, is 50. Okay, then, okay, QR, you know, is 120. Okay, so now by the Pythagoras theory, you know. Okay, we are going to quote the refined version. So your PQ that you are asked to find, is it PR? Forgive me, the distance between PR will be equal to root of, okay, PR is the hypotenuse. So it will be the sum of the squares of the other two sides, the legs. So that gives me 120, so 50, okay, squared plus what? 120, okay, squared. Okay, so that will be equal to root of 2500, okay, plus
14400.
okay, all right. So 12 squared, then you add 2 zeros. Okay, so in effect, we are going to get root of add, okay, for me.
16900.
Okay, so 169, okay, 00, which gives us 13.
130 kilometers.
Okay, so 13, then you bring your 169 will give, so then you bring your, the 102 square will give you 10. So you give me 130. Okay, so 130, okay, km. Today, Okay, Princess mentioned the units. Something will happen. All right. Okay, so this is what we have. But remember, you need to have your conclusion drawn. So you can write at this point, I can write therefore, okay, the length of PR, oops, okay, will be equal to what you have there. Otherwise, you come down. So I'm done with A. Or if you want to be smart, okay, you can keep your equal to and come and write therefore here. It's still allowed. So in that case, your conclusion is embedded in your method or your steps. Point well made.
Yes, please.
Okay, so I've told you when it is right angle, usually it is okay. The distance is very easy and the work will be easy as well. So now let's go and look at the bearing of R from P. R from P. So your reference point is P. So it means you are going to look at what? The angle between the true north line at P and what? The line joining your point of interest. And this one is R and P. So PR, this line. So we are looking at the measure of this angle. Okay, measure. So the angle between this line and this line measured in the clockwise direction. So we are looking at the whole of this. All correct? Okay, very good. So now I'm going to clear, okay, what I did in terms of my, okay, rough work. Your rough work that you have here, you can do it on your question paper. Okay, so that this space will be, okay, free. So do it somewhere that you can easily, okay, refer to. So now let's see what we can do at this point. So A gone. Okay, B, I'm going to look at the bearing. So bearing will be equal to, if you look at what we have here, you can see that the bearing will be the angle here. In actual fact, we have about 4 angles, but you can zoom it, okay, into maybe 2 angles. This angle, then this angle. But the whole of this angle, we know this is 90 and this is what? 45. Remember, that's the 135 angle. So I'm going to get what? My bearing to be 135 degrees, then plus, okay, this angle here. But you can see that this angle happens to be one of the interior angles of your triangle PQR. Can you see that? The entire angle here, this angle here.
Yes, please.
Okay, so we are going to, okay, label this angle theta. So the angle at P will be labeled, okay, theta. Okay, and we can find theta by using the appropriate trig what ratio. You know the opposite, you know the adjacent. So we are going to, so we said this will be plus theta. And we are going to find theta. So, but we know that tan theta will be equal to opposite, which is what? 120 over adjacent, which is 50. Do you agree? Is my point well made? Hello, my professor. Okay, great. So at this point, I can say that this implies that my theta will be equal to tan inverse of the reduced version, and that will be what? 12 on 5. Okay, so you use your calculator to give me the value, correct, to 4dp. I'm waiting.
67.380.
Come again.
67.380.
3801.
3801. Don't forget your degrees. I know this girl will forget. Okay, then, okay, 4dp. Okay, so this is what we have. However, remember, this is just theta. It is not, I mean, it's not the bearing, it's a means to an end. So we need to go and add the size of the angle, okay, to 135. Okay, so on that note, let me duplicate this and go and do it, okay, on my next page because I've exhausted this page. So we are going to continue here. I've cleared that. So that gives us what? All right, therefore, okay, my bearing of what? okay, R from P, okay, will be equal to, okay, 135 degrees, then plus, okay, what is the size of that angle? 67.3801, okay, degrees. And that will be equal to, here, I'm waiting.
202.3801 degrees.
Okay, degree. Okay, this is what we have. It will automatically give you 4 dp. However, can we end here?
No, please.
So as you read question, like I've told you, make it a habit to underline the salient part. There is a required approximation. So you underline nearest degree. So I write, okay, this is equivalent to, so I will take it to the nearest degree, which will be 202, okay, degrees. Is my point well made?
Yes, please.
Okay, very good. So this then becomes what? Your bearing. Okay, all right. So this question also dealt with. Now let's move on to our next question. Okay, all right. Question number 4. You can see that so far, okay, in all the bearing questions that we've solved, okay, the bearings were given in the true bearing form. However, in this particular bearing question, we have it in the compass bearing form. The bearings, okay, are given in the compass bearing form. So don't worry, it's the same approach that we are going to use. We know how to draw when we are dealing with the compass bearing, just as we know how to draw when we are dealing with the true bearing. Okay, so quickly, let's go and picture the situation, okay, roughly before we come and look at the true picture. Okay, so solution slide, let's see. All right, so I'm going to indicate my point maybe. Okay, so a ship sails from port R. So here you have points. So R, so my first point of interest is R. Okay, this is point R. But what's the bearing? North 65 east. Okay, so north 65 east means you move 65, okay, in this direction. So the angle there is 65. And remember, when you are dealing with a Cartesian, we said all the cardinal points must be indicated. Very, very useful. Okay, so you have your 65 here, okay, which you know is more than the 45 line. And what's the distance? 54. The other distance is what? Is 8. Okay, so small. So let's say this will go a little bit. It's a rough work, shouldn't be that detailed. Okay, you want to know the rough picture. Then the next one is south, okay, 45 degrees east. So south 45, okay, degrees east. So this is what we have. Okay, so 45 will be midway. So this is what we are going to get. Okay, but the distance here is very small. Okay, it's a very short distance. Okay, so indirectly, this is going to be the picture. Then you go. So, all right, so now I know the area that I would need most, looking at the picture. Okay, so I can go and start what? My actual drawing. Are you following? My
Yes,
professors,
please.
are you following? Great. Okay, so I guess you are also practicing. You are following exactly what I'm doing. Just don't just look at it. Okay, there's a practical situation. Okay, so now what do? I go and pick my straight edge, then I start drawing. Okay, so I know my plan and I'm working according to plan. Okay, so what do we have? Not okay, so from the point R, port R to port S. Okay, so now S will be somewhere up there. So I know the picture. So I'm going to have this situation. Okay, I'll come down a little. Okay, so draw. Okay, come and draw my vertical line as well. Okay, so I have my north. Okay, remember I'm dealing with the compass bearing now. Okay, my north, okay, west, east, then south. Okay, if possible. Okay, let us see the ray. Okay, so now, okay, the first one, we said the bearing is north 65 degrees east. So north 65 degrees east. So you need to measure 65 from the north towards what? The east. So that angle will be closer to the east than to the north lines. Okay, so now, okay, though you are not drawing to scale, remember the picture should be, okay, should make sense, sensible. All right, so now what do we have? Okay, I'm going to draw indirectly. The distance there is what? What's the distance? Is it the 54? Okay, so this is the longest distance, so you can go as far as you want. Okay, so the longest distance I want to end here, then I will do this. The other one, okay, will be shorter than this. Okay, so I will indicate my cardinal points also there, or even my true north, very critical. Okay, so I come and indicate. Okay, however, remember the angle here, okay, you need to indicate. Okay, so this is 65 degrees, okay. Then you come and indicate your north, okay, west, east, then south. Okay, so now what do we do? The other one, we are told that it then sails on a bearing of south, okay, 45 degrees was east. So now this is where you are. That is the point S. South, okay, 55, okay, so degrees was south 45, forgive me, degrees east. So this is your south, this is your east, and that is more or less. So it means we didn't get a true picture. Can you see that?
Yeah.
Okay, so we should have taken our reference point from here. Okay, not from the first point. So it is not a true picture that we have drawn here. So take note, but fortunately, at least we'll have space to contain our lines. So you can see that if you don't bring out the true picture, assuming this was it, you thought this is the picture, and it's only this side that is your page, and you need a line here. So you should know the obvious. You have to go and erase. Effort wasted. Okay, so now what do we have? We are going to draw north, okay, sorry, south, 45, okay, east. So it's going to give me this. It's a very short line. If you look at it, okay, we have the other one is 54. This is just 8. I'm thinking it's supposed to be 80, but let's assume this is the situation. Okay, a very short one. So you end there. It will be very short, looking at the distance. Okay, so this is what you have. Okay, I think there is something wrong with that, but no issue. Okay, it could be a correct question. Okay, you don't have any negative angles or what have you there. So you are good to go. Okay, so you indicate your true north, okay, also here, or your cardinal points there. So you have your north, okay, south, west, then east as well. So now you come and join this. Okay, so look at the picture that will come out of that. Okay, if you extend this line a little more, okay, you see that you get a different picture altogether. And sometimes the angles that you'll be looking for can give you, okay, a hint that your diagram, there is a problem with it. So what is happening? Okay, so let me see. I will manage and draw. It lies bad. Okay, good. So let me draw like that. So this is what you have. Okay, we didn't consider our angle. So from this one, we said south. Okay, it's 45 east. So this will be 45 degrees. You know that angle, 45 degrees. Okay, so now let's see if you can find any known angles Obviously, we know that the angle here will also be 65. Is that clear? Is my point well made? Okay, the distance here is 8 km. Okay, the distance here, okay, is what? 54 km. All correct? Hello, are you following? Did you get the exact picture here or close to this?
Yes, please.
Okay, so please take note. When you consider your distances and the bearing, the angles, which one it will be close to and what have you, always the diagram will be very, okay, representative. All right, so now what do? We are going to, okay, solve. Unfortunately, this time around, the angle here is not what, 90. Can you see that? The known angle of what? Your triangle there, which in this case, did I indicate my first port? Okay, this is port R. I didn't indicate my R. Okay, port S, and from S towards Q. So this is where Q will be. All correct. So QRS triangle, QRS obviously is not a right angle triangle. Okay, so now let's see what we are supposed to do. The question is asking us to find the distance between R and Q. So we are finding this distance. But unfortunately, okay, once again, we are not dealing with a right angle triangle. Okay, for you to use the Pythagoras theorem, our usual Pythagoras theorem to find any unknown side. Okay, and the trig ratios to find any unknown angles. So here, this is how, okay, you are going to deal with it. So I'm going to equally extract not only when your picture, okay, is that of a right angle triangle that you indicate. Okay, so let me, okay, draw this here. This was my east line. So let me indicate it well. Okay, then I'm going to rule, assuming this is my next page. Okay, so on that note, then it means I'm going to have my diagram drawn here. Okay, just as I had my right angle situation triangle drawn. So this will be the angle there, 45 plus what? Plus 65 will give us what? Is it 110? So it means you have an obtuse, okay, triangle, angle triangle. So this will be the nature of that triangle. Okay, so please take notes. Okay, this is just a helping diagram. If you can make your analysis or do your analysis with the original one, go ahead and do so. Okay, all right. So this is the situation. So my angle, okay, which is the 110 is at S. Okay, obviously I cannot, if I bring it here, this angle obviously is less than 90. So it cannot be that situation. So this is the 110 degrees. Okay, I can fix my, okay, other two anywhere. So maybe I have my R, I have my S. Okay, so let's see any, oops. Okay, so let's look at any side that is known. I think now I don't need the straight edge again. So let me, the ruler again, let me.
Mr. Hartman,
Yes, please.
please, you label two sides as
Yes, okay, so
two
forgive me.
corners.
So this will be Q. Okay, all right.
Yes.
The two vertices. All right, okay, so now this will be 8. SQ is 8 km. Okay, then what else? SR is what? 54 km. So the diagram, the busy diagram that you have here, okay, you can see that this is better. So if you want to use this one to do your analysis, find any unknown sides, any unknown angles, okay, you can do so easily. So let me go and clear, okay, what I have here. Okay, so now we are good to go. Okay, so what do we have? We are going to look at the solution to A. We are looking at the distance between R and Q. So we are looking at this distance. Okay, unfortunately, we are not dealing with what a right angle triangle. But you know, anytime you have a non-right angle triangle, okay, and you have two known sides and an included angle. An included angle is the angle between any two known sides. So this side is known, this side is known. You can see that the angle that you know here is the angle between two known sides. This angle here is between one known and one unknown. This angle here is between one known and one unknown. So the included angle here in this situation will be these two known, okay, sides, okay, this angle, forming that angle. So it's the angle at S, that is the included angle. Okay, and whenever you have this situation, we have to use the cosine rule, okay, in finding the unknown side. Is my point well made?
Yeah.
Okay, and you all know, who doesn't know the cosine rule? Okay, so once you all know, then it means the work is going to be very easy. So in this case, okay, someone should help me deal with the cosine rule. By the cosine rule, the side that I'm looking for, which is RQ or QR. Let me use, okay, it's the distance between RQ. So let me use RQ, though it's the same, but I can use QR, it's the same thing. Okay, it will be equal to, it's not named after a person, so you can choose not to write by the cosine rule. Cosine is not a name of a person. Okay, so just quote it and use. So you can write, but will be equal to, I'm waiting, my professors. The other side, okay, squared. So maybe 54 squared, then plus, okay, 8 squared. Then minus, I'm waiting.
Minus 2.
Minus,
2 and multiplying 54 and 8.
okay, 2 multiplying the two known sides. So 54, okay, and what? 8.
8.
Okay, but that's not all. Then cos
Then
of what? Your included angle, which is 110 degrees. Is my point well made? Hello, my professors. Are you sure you are with me?
Yes, please.
Okay,
But Mr.
so
Akma, please come again.
I should come again. Okay, this is the cosine rule. Anytime you have, okay, a triangle, maybe A, B, C, we usually will say that the side opposite, let me call it the vertex a small, okay, letter A, opposite, okay, B, opposite small letter C. So we'll say that your A here, if we are looking for A will be equal to, okay, please take note. Is this one squared or it's not squared? Hello, your cosine rule, is it squared or it's not squared? It is squared, right?
Yes.
Okay, so if you want to, then you can write the square root here. It's the same thing. If you don't want to square it here, then write the square, so that it will be the refined version. So we'll say that your A squared, okay, if you take this side squared, it will be equal to the square of the other side, so you sum. So that is the other side, you have B squared plus what? Okay, C squared, then minus twice the product of what? These two sides, okay, BC, then cos of what? Your included angle. And the angle will always be the angle opposite the side that you are looking for. So in this case, the angle at A. So A angle. Okay, if you are looking for B, it will be B squared is equal to A squared plus C squared minus 2AC, then cos of what? The angle at B. And same for C. Is my point well made now? Okay,
Yes, please.
this is something that you need to know in, okay, trig, formal trig. Okay, so at this point, I'll write, this implies that, okay, I know my QR, okay, squared. So let me keep this, not that I know its value. Okay, that's what I'm looking for. So 54 squared, I'm waiting. Okay, so let me leave this one with you. Okay, or maybe some of you don't get it. So 54 squared, you write the value there, plus 8 squared, you write the value there. Okay, then minus, okay, twice the product of this, you write it there. Okay, then cos of what? Your angle 110. Okay, and it will be calculator way, as simple as that. So use your calculator. If you are not following, please let me know and give me the value of QR. So QR will be the root of whatever that you get there. Okay, so give me the value of QR. If someone is done.
57.2320.
Okay, so 57.2323. If she's right, I'm also right. And what is the distance? Okay,
8.20.
okay, so
For
let me
the
see if maybe Kobe has. Okay, I saw, okay, maybe it's gone. So the unit there is what? KM. Okay, then you indicate your 4 dp. Okay, now, okay, when you read a question, there is an approximation. So I've told you as you read question, you need to take note of the approximation. So you underline maybe 1 dp. Okay, it's 2320, not 23. Not 2323. Is it 20?
Yes, please, Mr. Akman, I said 20.
Okay, so I didn't hear. Well, network issues. So pardon me. So if you say something and I write it's something different, prompt me. Okay, if you don't prompt me, then it will assume like, okay, that's what you said. You get it?
Yes, please.
Okay, good. All right. So now this is it. Okay, for your distance between, so you draw your conclusion, therefore QR. Instead of writing the distance between R and Q, okay, the distance between R and Q mathematically is this. So write it this way. Is that clear? Okay, so on that note, okay, that will be it for the QR. Now let's go and look at the B. B, we are looking at the bearing of Q from R. Q from R. Okay, so our reference point is what? Is R. Okay, so you are looking at the angle formed, please listen carefully, by the true north line at R. Okay, and the line joining your 2 points of interest, and in this case, QR. So that line was RQ or QR, but measured in the clockwise sense. So it means you are looking for the entire angle here. All correct. Is my point well made? My professors, are you there? Is my point well made?
Yes, please.
Okay, so
Yes.
at this point, what do
Yes.
we do? We are going to get the bearing. Now we know how to plan and get the bearing. So the bearing will be equal to, remember this angle is 65. So 65 degrees. Then plus this angle, which happens to be one of the interior angles. So let's call it theta. So plus theta. So theta is the angle here, is the angle in your triangle by the triangle at R. So this is theta. All correct. Okay, like I said, any other analysis, okay, it is better you use this. So how do we find theta? Obviously, we cannot use what? Okay, any of the trig ratios, because you should know that we are not dealing with a right angle triangle. So it's when you have this situation, it's either you use the cosine rule or sine rule to find. Okay, so we should use the sine rule. Very good. Okay, so in this case, this is what we know this side indirectly. So this side is what 57. Okay, point what 23. okay, 20 p.m. That is what we know. Okay, and if I may ask, is it possible to find theta without making use of any side or any angle that we have found? If you want to use, okay, find theta using the sine rule, okay, obviously, are we going to involve the 57?
Yes.
Okay, so we cannot. So in that case, okay, we have to. So questions like this, my point is, the reason why I ask questions like, usually in math, you avoid, okay, making use of what you have found to find a new value. So if you can use the original or, okay, already given values, use that approach rather than going to find something and you come and use it, because whatever you are going to find, there's a possibility of you getting it wrong. So if it is wrong, you are doomed. So with this one, it means if this value here is wrong, we are equally doomed, because the sign rule that we are going to make use of a garbage. So garbage in, garbage out, sort of. So in this case, okay, we said we are going to make use of the sign, okay, rule. And we said, if you have this situation again, this triangle, okay, you are going to get sine of the angle at A over the side opposite A. The angle A should be equal to sine of the angle at B over the side opposite the angle, the vertex B, and or the angle B, and that is what B, and that should be equal to sine of the angle at C. So let me put, okay, the angle notation there or symbol, so C. However, okay, you form your proportion in such a way that you need only one unknown, or you have only one unknown in your proportion. So you remember I said this when we were doing the similar figures, when we were forming, okay, the proportion using correspondence side, I made mention of this. Form your proportion in such a way that it will involve only, okay, one unknown. Even with this one, okay, you can also quote it this way. This is the sine rule with the sine of the angles on top being the numerators. We can also say that it's A over sine A angle A is equal to B over sine angle B is equal to C over sine angle C. Okay, however, it is usually advisable to quote the first one if what you are looking for is an angle. It's advisable to quote the second one if what you are looking for, your unknown, okay, is a side. So if your unknown is a side, the sides must appear in the numerator. If your known is what is an angle, the angle must appear in the numerator. So you quote the one with the angles appearing in the numerator. However, you can quote any one of them. Only that if you are looking for an angle and you come and quote this, you will do more work in terms of the change of subjects. That is simply it. Okay, otherwise you can use one for all. Okay, so now, okay, we need to go and find theta, one of the interior angles. Okay, so we said the sine rule. So it will be, we are looking for this. So I'll write sine of the angle theta. So I will let, okay, that one be, so I know, but sine of the angle theta over the side opposite the angle theta, which is 8, should be equal to, okay, I have to use a known angle and a known side. Other than that, I will get two unknowns. So it will be equal to sine of the known angle 110 over sine of the angle, did I say over the sine? Over the length, okay, of what we have there. Okay, forgive me. So over, okay, the length, which is what, 5, 7 dots, what, 2, 3, 2, 0. Is my point well made?
Yes, please.
Okay, so in this case, you, okay, continue to find, okay, your, so let me see if I can duplicate it, then we continue from there. Okay, so at this point, I think I can pause, then do the needful, come and resume. Okay, so at this point, you know, I've told you, try and avoid your number of approximations that you do in one question. The more approximations you do, the more you move away from the actual, okay, or the expected answer. value. So come and multiply, and it will be, please don't write it as sine 110 degrees 8. Okay, the constant should come. So it's like 8 sine this. Just as I wrote it here. I'm waiting. I think by now, someone should be done with the value. Hey, I'm waiting. The 4DP version of what we have there. Oh, no one has that. Wow. Hey, so what are you using your calculator for? Give me this value and let's go. Okay, so 7 points. 7 points. That's the final answer. Are you talking about the inverse? The sine inverse? Okay, so then I'm going to leave this. You do that. So it means that, okay, theta will be equal to sine inverse of whatever that will be here. Okay, then after that, we said theta will be equal to what? 7 point what? 5, okay, 477 degrees. And don't forget to indicate your 4dp. So 4dp. Okay, and remember theta is only a means to an end. So we are going to add theta to this. All right, therefore, okay, my bearing, okay, my bearing, okay, of Q from R. Okay, let me, okay, will be equal to, we said it will be 65 degrees, then plus 7.5477 degrees. So which gives us, okay, so we are going to get 72 point what 5477 degrees. Okay, so in this case, this will be equal to, we said 1 dp. Is it 65? 65 plus 7. Okay, so I'm right. Okay, so that's it. So we are going to get, let's go. So that gives us, to 1 dp will give us 72.54 degrees. Then you write 1 dp. All correct. But take note, do you have any issue with what I have there?
Yes, please.
What is it?
Please, it should be in 3.
Digits. Okay, so you are right. The whole normal part should be 3 digits. So you precede it with 0 in your conclusion, your final statement. Is that clear?
Yes, please.
Very good. So please take note of that. Okay, so we've done one question on, okay, the non-right angle triangle. Maybe we'll do one more. Okay, then I know you are fully insured. But before that, please, we are going for a water break. We've done a little over an hour. Okay, so we'll come back and look at, okay, the rest of the questions. So by, okay, 5:10, you should all be back. Okay, so welcome back from the water break. Okay, so this is going to be our next, okay, assignment, basically. Okay, so now, okay, I don't know. Okay, I think it will be better if I duplicate it. I don't want to be moving front and back. Okay, I will duplicate it and see if I can, let me reduce this. Okay, then use it. Okay, so this is going to be my solution anyway, sort of. So let me do the needful. Oh, it's in caps. Okay, all right. So we are going to look at the solution to this particular one. Okay, so let's go. I'll help you up to a point. Okay, so let's get the diagram, the rough picture. This time around, let's get the right rough picture. Unlike the other one, we were saved though, because of how we started. Okay, so two, okay, point A and B are on a bearing of 40 degrees and 120 degrees respectively from a point O. So all of them, they will take their reference point, the point O. Okay, one, the bearing is what? That is that of the A from O. The bearing is 40, so it will be somewhere here. Okay, and OA. Okay, so that is if you want to, OA is 12. The other one, so this was the shorter or the short one. So that is 12. I can ignore. Okay, 40. The other one from O, okay, to B, the bearing is what? It's 120. So 122 will be somewhere here, but this one will be longer than that. So we have, okay, a rough picture. So we can now go and draw. Are you following, my professors? Are you with me?
Mm.
So we know the area that we'll need more. So I can come and fix my O here. One will go up, one will come here. Okay, so we are good to go at this point. So let me go and pick my straight edge just as you have also picked yours. Then let's go and start, okay, drawing the true picture. Okay. What is happening? Okay. Ah, why is my straight edge going? Okay, I think there is a problem. I will deal with it. Don't worry, pretty soon. Okay, so this is what we have. Okay. All right, so let me clear one of my lines. I shouldn't have any double line anywhere. Okay, all right. So we are good to go now. Okay, so what do we have? This is the point O. Okay, indicate your true north. Now, you are not dealing with what? The compass bearing. So the angle there is for the first one is what? Is, okay, 40. So you know 40 is supposed to be close to the midway, which is the 45. But it's supposed to be close to the north, okay, down to the east line. So you know, okay, I have the exact angle. I can get it. Okay, so let me, oh, what is happening? Why is it not showing up but down? Okay, so that distance is what? Is 12. Okay, so let me, I think I've gone beyond, but it's okay. Okay, we can still indicate our cardinal points there. Okay, only that, let me see. Okay, I think I can move. It doesn't change anything, but make sure it doesn't go beyond where it's not supposed to go. Okay, so at this point, I don't know what is happening. Okay, but we'll manage, no issues at all. This cannot stress us. Okay, so we have this situation. Okay, then now, so this angle here, you know, is 40 degrees, indicates the distance there, you know, is 12 meters, indicates. Okay, then this is the point A. Okay, with your true north there as well. Okay, now we are told from O to B, the bearing is 120. So 120, okay, you have 90, and you need how many more? You need 30 more. So this is what is going to happen. Okay, 30 more. 30 will be closer to the east line than to, okay, the south line. Take notes. Okay, so let me, okay, draw this one. Okay, 30, but the distance there is 15. It should look more than the other one. Okay, and it's looking more than that. Is my point well made? Okay, so now what do we have? We can now come and indicate our, okay, I knew this will go inside, so I should have, okay, maybe I'm using, so, okay, then come and indicate. Okay, I'll bring it closer, don't worry at all. Okay, so now, Okay, you bring it down. I guess you are also doing yours. Okay, so this is what we have. Okay, and I am going to do this. Let me see. Okay, so this will be your north. Okay, and this will be your point B. So you join A and B. So I'm going to join A and B. Okay, I didn't indicate my distance. I will come and indicate. Don't worry. Okay, so I'm going to join A and B, and I will get this picture. What is happening? Okay. So A and B joined gives us this. Okay, so this distance we know is what, 15. Okay, meters. Okay, and any angle that okay, here we added we're looking for 120, so we added 30. So this angle here is 30. Always indicates any angle and your point must always be, your lines must meet at the common vertex. Okay, so at this point, this is what we have. We are more than good to go. Okay, so now let's see. What then do we do? Okay, let's check what we have there. Okay, so now any of the angles that we can find, yes, if this is 40, this will be 50. So we know this interior angle. So unfortunately, it's not a right angle triangle. Okay, it's giving us 80 degrees. So it means we have to use the cosine rule or the sine rule, okay, appropriately to find whatever that we are supposed to find. But because here we are asked to find only the distance usually will require the cosine rule. It is the angle that will bring in, okay, the sine rule. Okay, so at this point, okay, if you can do your analysis straight away, you go and do your analysis. Only that I always prefer getting a rough sketch, okay, better to do my analysis. So assuming I come and draw, so I'm going to have, okay, this kind of situation. Okay, you let me use it so that you also know how to use the diagram without reproducing. So the whole of this, let me go and clear it. Okay, so at this point, what do we have? We are going to get, okay, we are looking at the distance between A then B, this distance. So we know that AB squared by the cosine rule, okay, should be equal to, remember, it will be the other side squared. So let me put it in terms of the length, the vertices, then now I come and use the actuals. So the other side will be OA, okay, the length of that squared, okay, plus the other length, which is OB, the length of that squared, but that's not all, minus twice the length of AOA, okay, the length of OB, but that's not all again. The cos of the angle at what? At O. So cos, okay, of the angle at O. Is my point well made?
Yes.
So you can see
Yes,
that that's the more reason why I always tell you that if you can avoid introducing, okay, O, you avoid. But here you cannot, because A, you didn't introduce it, was given in the question. So you are compelled to use it. Other than that, if it was just A, okay, I can just write cos A without bringing the angle. But if I go and write this cos, then leave it this way, you can see that it's looking like cos 0. So you always avoid in math, you always avoid introducing the letter O, okay, because it can conflict with what 0. So now I have the O, I put a cap on it for you to know that you are looking at the angle O, not 0. So at this point, you go and substitute, right? Maybe therefore here, my AB, okay, length will be equal to root of, then I will go and substitute. So OA is what? Is 12. So 12 squared plus OB is what? Is 15. So 15 squared minus twice your OA, which is 12, OB, which is what, 15. Then cos of what? The angle at O, which is what, 80 degrees. So make sure you extend to cover. So at this point, I guess you can continue. Is that not it? Who cannot continue and would want me to continue? In any case, this is a past question, so I've guided you. When you go, you can relate with the continuation. Okay, so let's move on to our next question. Are we all fine? Is everyone okay? Yes, Princess.
Please, I can't see what you've written, the last part, like root. Is it cos 800?
No, of course, 80 degrees.
Yes, please.
Is the degree that is appearing like. Okay, so let me write it well. Oh, this one I can go back. Let me see. I think if I need to go back, I wrote a lot before. Okay, so let me do the needful. I'll write 80 degrees. Let me edit here. 80 degrees. Okay. All right. So now we know we are good to go to the next question. We are all fine. Okay, we have to exhaust all the questions here. Okay, so let's look at the next one. Okay, the questions are carefully selected. Okay, in certain situations, okay, the diagram will be provided for you, and you are supposed to use the diagram, okay, to answer the follow-up questions. So your bearing diagram provided here. So let's see what we are supposed to do with that. We are supposed to calculate correct to 3 significant figures. So we underline that. Okay, anytime you read and you see a required approximation, underline. Okay, so first of all, we are doing AI. So this one, I think we can do it here. We are not going to reproduce what we have there. If there are any additions, what have you, you can do it there. So I'm going to have this. So let's go. Okay, and look at it. Well, so I'm looking at AI. Okay, so AI. AI, what are we looking for? Calculate correct to 3 significant figures, the length O, okay, Q. So you know, OQ length, cosine rule, OQ length will be equal to, I'm putting the refined version. So that will be equal to the other side, okay, square. So 10 squared plus what? 6 squared minus twice the product of 10, then 6, then cos of your angle known. So you are going to look for your angle known. So your angle known is the angle opposite OQ. So you have to go and find that angle. So here, if this is 160, we know that this is 70. Do you agree? Hello, do you agree? The
Yes.
angle here
Yes,
is
please.
70. So if this is 70, this will be 20. Do you agree? We need to find
Yes.
this, then we know. And we know that this and this are, okay, parallel, so a transversal. So the angle here will be equal to the angle here. So it means this is also 40. So in effect, we have 60 degrees here. So we are going to have cos 60 degrees. Then you can continue. So this is also looking like a 600. Is my point well made?
Yes.
Yeah.
Okay, so you move on to go and find that. I won't exhaust. Okay, the rest will be calculator work. Then we need to find the bearing of what? Of Q from O. Q from O. So where is our O? O is this. Q from O. O is the reference point. So we are looking at the angle between the true north line on O and the line, okay, joining the 2 points. We said Q from O. So the 2 points are Q and O. So this line, so it means measured in the clockwise direction, we are looking at the angle here. So if you look at it, okay, the II, okay, the bearing, okay, will be equal to the 40 degrees there. Okay, plus what? The angle theta here, which will be one of the interior angles. So you need the sine rule to find it. Okay, by then you had found, okay, this up here. So you can continue. Is my point well made?
Yes.
Okay, so now let's look at what's the B. How far south of P is Q? How far south of P is Q? Okay, so this is all that you need to do. P, south of P, you come down. I'm only guiding you. Okay, it's Q. So how do we connect the two? I'm waiting. How far south of P is Q? Hey, am I recording?
Yes.
Yeah.
Okay, so I'm waiting. I shouldn't have to always, okay, spoon feed you. Let me see, tell me how you understand the statement that you have there. How far south, okay, of P is Q? Correct to three, okay, significant figures. Don't let us waste time. Okay. Anytime you have this situation, this is the picture. We are looking at what? A line, okay, the angle between a certain vertical line and a horizontal line through your 2 points of interest. So you are looking at what? Okay, this particular distance, this distance here. Do you agree? Let me see whether indeed you understand. You are looking at this distance here. Is this distance that you are looking for? Is it the distance? Wow. Okay, you think about it. I don't want us to. We'll come back to that. Okay, let's move on to the next question. Okay. So this particular one too, okay, we'll just let me see whether I have a response. Okay, I wasn't saying anything, okay, for a fact. I asked the question. I wanted to play with your intelligence. Okay, so here the question said, you want me to go back, so I will go back. Okay, then we'll come. How far south of P? So south of P means you need to come down. Okay, it's what? Q, because south of P is on this line. It's Q. So when you come down, you look at what? A certain line that will form. That's the trick. I've given you the first trick. Okay, down this. So vertical, you need a horizontal line through your other point of interest. Okay, to form a 90 degrees angle. And you can see that in this situation, you have two distances, the distance here and distance here. And we are saying that I asked, is it the distance that we are looking for, which is how far it is from what, how far south Q is from P, or this is the distance. So it's either this distance or this distance. So think about it. I will come back. Then whichever one you pick, you tell me why. Okay. 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 So you have given your answer. We'll come back to that. Okay. I'm happy you said you added you suppose. Okay, all right. You're adding more flesh to that. I like that. Okay, in actual fact, let me say it is this distance. So you come and find this distance, that's all. You can find it because you know this distance, okay, and you know this angle too. So with appropriate trig ratio, you can find this. Is my point well made?
No, please.
Did you say no?
Yes.
Let me see who was that. Who was that? Okay, Shira, okay. All right, so this is it. How far south okay, of P is Q. So it means here you can south of P will be down on the south line. Is that not it? So
Yes, please.
how far are you supposed to move down south to locate what P on a particular line? Indirectly, that's the meaning. Okay, so you need to come down here before you can locate what the Q. And I said that usually you have to draw a line, okay, through your points of interest. One will be horizontal, one will be vertical. So this one you can see south means you are going to draw the vertical line, and this one will take the horizontal line. So 90, we are looking for this distance. And I said, you know that this angle here is 20. So this right angle triangle, you can find the side because you know the side and one angle. As simple as that. Is that clear?
Yes, please.
Okay, great. All right. So now let's come to this question that I was about looking at. So this is it. Okay, so you can see another one. How far east of what B, okay, C is or is C? That's what you are asked to find. So in this case, to how far, okay, east. So east of B is this. So it means you are going this time, right? You're going to draw, okay, a horizontal line through B, and the C is the one that will take the vertical. You get the point. So this time round, remember we are looking at this distance instead. So always the distance should be on, okay, off. Okay, that's your reference, okay, point. So it is this distance rather that you are looking for. And again, this will be 90. Okay, this side will be known because the information here, this diagram here, okay, some of the information hidden in the statement form here. So you are told AB is what? Is 13. So this is 13, okay, km. And you are told that BC is what? Oh, AB is 8, forgive me, and BC rather, that is 13. So you know this to be 13. So again, you have a right angle triangle with one side known and one angle known. So you can use the appropriate trig ratio to find, okay, this side. If you choose to call this X because it's on the X axis, the other one you can call it what? Y. Okay, because you are looking at what? That's why I said Y. Okay, you can call this one X as well, and you find it. It's the point well made. So it means we've done indirectly C. So let's go and look at the A and what and the B. A, we are supposed to look at or look for the distance AC. AC is this distance. Okay, you know this, you know this. So let's check whether we can find any known angle. Yes, this will be 50 because I'm looking at the whole of this to be 90. Okay, and let's see what we have here. If this is 50, this angle here will also be 50. Do you agree? Hello, do you agree?
Yes,
So
please.
it means you have an included angle that will be 100 degrees. Okay, so it becomes just like what we've been dealing with, where we even have to draw the diagram to bring out the picture. So here the picture is given, just use it. Okay, and you are asked to find the bearing of C from A. So your reference point is A. C from A to be the north line, okay, at A. The angle measured clockwise to the line joining your 2 points of interest. In this case, my points of interest are A and C. So AC. So I'm looking at this angle. Is that clear? Hello, is my point well made? Okay, and here I'm going to give you a very vital information. Okay, you can see that, okay, let me even ask, how would you find this bearing? Okay, who can guide? I want someone to guide us as to how to find the size of this angle. I'm waiting. Okay, so let me see. Okay, in certain situation where you struggle to find your angle, okay, that is here, and you are looking at what? The bearing of what? C from A. Go and check whether the other bearing, which is the back bearing, you can easily find it. If you can easily find the back bearing, use the back bearing to find, okay, your front bearing, because you know how to find the back bearing and front bearing. Okay, I think exactly that's what you are saying. Okay, so we are on the same, okay, line. So in this case, you can easily come and find this angle. The bearing of what? A from C. You can find from here to here. And once you know the bearing of A from C, remember you know the bearing of C from A. So this one will be 90 plus 50, then plus one of your interior angles of the triangle. So you go and find that interior angle, add it towards, this will be 180 plus 50, which will give us what? 230. Okay, so 230 then plus this your theta. When you add it, obviously you have exceeded 180. So it means your result that you get, your final result, which will be the whole of this, okay, you subtract 180 from it, and that will give you your bearing of what? C from A. All correct. Okay, and there is one interesting question here. That's going to be our last question. Okay, indeed. Okay, so please start drawing the picture that we have here. And let's see, immediately you get stuck, okay, or you struggle. Let me know the point that you are going to struggle or you struggle. That's not to say that you have to struggle, please. So my point is, deal with the diagram, okay? Even if this is not there, you know you will draw it. Okay, so give me the picture that you have here. Okay, I'm waiting. So let me pause. Okay, so let's get to the picture first. Once we are able to get the rough picture, okay, then you should be good to go. So the rough picture, what do we have? The bearing of what? Q from P. So my reference point initially is P. Okay, and the bearing is 150, so that will be here. Okay, so Q from P, so my Q is going to be here. Do you agree?
Yes, please.
150, I will add a
Yes,
second
please.
under 90. Okay, now let's look at the second statement. Okay, and the bearing of P from R. So where is your R that you are going to take your bearing? You get it? Usually you get your point, then you can go and get your Cartesian, okay, I mean your, that's a Cartesian, your compass bearing, you indicate it there, then you get it. So how do we get this? We don't have R. So how do we take what? The bearing from R? We only have P and Q. Okay, so what do you suggest we should do? What do you think we should do in this situation? Any suggestions? Any ideas? Okay, so once again, this is where you apply the concept of what? Back bearing. Okay, you've been given the bearing of what? Of P from R. Okay, and that is equal to what? 0.15 degrees. Okay, however, you don't know R, but you know P. So it means you can draw this, okay, in another way, which will be you looking at it from R from P. Okay, and that will be equal to, remember this is less than 180. So it will be 180 plus this, which will give us 195. Is my point well made? So
No,
once you
please.
get, okay, so you can see, as for the fact that you don't have R to take your bearing from, you are fine. Is that not it? That is the knot in this question. If you are able to untie it, then you are good to go. So we are saying that if I don't have R, okay, to take my bearing from, I have P to take my bearing from. So I can look at it in terms of the back bearing. I can still locate my R. If I'm not able to locate what my P from R, I can locate my R from P. Is that not it? And it will basically be the same situation. So the bearing of P from R is 105 degrees. Remember, yesterday we did the back bearing. So the bearing of R from P, if your front bearing is less than 180, you add 180 to get your back bearing. So that gave us what? So if you are not here and you've not watched the video and you are struggling, then you know that's the reason. So we have done that. So you get 180 plus 15, which will give you 195. Okay, so at that point,
Mr. Hackman,
yes, please.
couldn't you have used the P from R like that?
Couldn't you have used?
The front bearing.
Okay, so from R, so how are you going to get it?
You draw the R.
Okay, so how will you draw the R?
Like you draw the 15 and you make it touch the P.
You draw Okay, all right. So I don't know how you are going to, but we can be smart. Okay, but the way you are explaining it, that is my issue. Okay, but I just want you to know this is the easiest way to get your diagram drawn. Anytime you are given a situation where the point that you are taking your bearing from is not given or it's not stated, okay, meaning you can't get it on your diagram, okay, you've not indicated that point anywhere, please use the back bearing. It is very useful in such situations. So in this case, I'm going to use the back bearing. The back bearing is trying to tell me that in order to locate R from P, it will be 195. So I come and stand at P, okay, 195. So this is 180. So 195 will be somewhere. So 15, I'll add 15. So it means it will be somewhere here. This is where your line will be. You get a picture, then you move on. That's the only note in this question. Is that clear? Is my explanation okay?
Yes, please.
Okay, so the point is, so now we know so far how to deal with bearings when you are given true bearing. Okay, your bearings are in the true bearing form. Whether your triangle results in a right angle triangle or a right angle triangle, you are good to go. And in this final situation, okay, where your bearing, the point that you are taking your bearing from, okay, you don't know, you've not indicated it, okay, but you have indicated the other points, okay, use the back bearing, which will take a source from the other points to find, okay, your other point that you couldn't indicate. So please take notes, okay, of that. So these are the various ways that you could be trained. And you also look at a situation where the diagram is already provided and how to do your analysis. Okay, so on that note, okay, thank you very much. Okay, we are through with what the topic bearing. So vectors and bearing also done. So the format topic left, okay, will be, I think, mensuration. Okay, even that one won't do, okay, everything. I'll restrict myself to maybe the circles and what, and the cone. Okay, so thank you very much once again. Please, okay, take care, stay blessed.